Hyperbolas are the last of the, so now we've got circles, parabolas, ellipses, and hyperbolas, right? The last of the 4 conics that you're going to be tested on. So this is next Wednesday's test, a week from today. So you want to make sure you know all the stuff for circles, all the stuff for parabolas, and all the stuff for ellipses. So if you are keeping track, circles should be the easy ones, right? Circle has x minus h squared plus y minus k squared equals r squared. The center is your hk. The radius is your r. Then we moved into parabolas. And there are 2 kinds, the vertical and the horizontal. So if it's x minus h squared equals 4py minus k, then this is your up or down. If it's a positive 4p, then it opens up. If it's a negative 4p, it opens down. And then you had y minus k squared equals 4px minus h. Positive 4p opens to the right, negative 4p opens to the left. For this one, you needed to know the vertex, which is your hk, and then the p is the distance from the vertex to the focus, which is a coordinate point, and vertex to directrix, which is either an x equals or a y equals because it is a line. Then we moved into ellipses. And again, there are 2 kinds. There are horizontal and there are vertical. The horizontal is x minus h squared over a squared plus y minus k squared over b squared equals 1. And the vertical is x minus h squared over b squared. Order doesn't matter here. Y minus k squared over a squared equals 1. The biggest thing is that a is the larger denominator.
When you say order doesn't matter, what does that mean?
That means I could have the x or the y first or second. It doesn't matter. What matters is which one has the bigger denominator. That's what determines if it's vertical or horizontal. You're going to see today when we get into hyperbolas, order matters because there's a minus between them. And then for each of these, or for all of this, your center is your hk. The a is the distance from center to vertices. B, center to co-vertices. C, center to focus. C squared equals a squared minus b squared. Major axis is 2a, minor axis is 2b, and eccentricity is c over a. Closer to 0, the more rounded, closer to 1, the more flattened out. We're going to do that again before your test. Like the more times you write it out, the better it sinks in. All right, now we get into hyperbolas. So there is a lot of overlap between hyperbolas and ellipses, but they are very, they look similar in equation format, but they are very, very different when we go to graph them or if you are, trying to find all the parts, okay? So a hyperbola is the set of all, in definition, a set of all points x, y in a plane, where the difference of whose distance from 2 distinct points, the foci, is a positive constant. So if you remember the ellipses, it was the sum of the distance between those, and now it's the difference. So ellipses plus, hyperbolas minus. So a hyperbola looks like 2 parabolas that point away from each other. This is a vertical hyperbola. They can also be horizontal. So you've got, these are called branches, and then you're going to end up having 2 things called asymptotes that are going to separate them out. That tells you how wide, or you remember this now? Yes.
So instead of positive, it would be negative.
Correct.
Okay.
Yep. So the parts of the hyperbola, okay? We just said it, but the two they look like parabolas, but those two curves, they're called branches. So vocab term there. The line through the two foci intersects the hyperbola at 2 points called the vertices. So just like a parabola, they still have vertices. The line segment connecting the vertices is called the transverse axis. So instead of major axis, okay, this is like major axis, it is now the transverse axis. That means the one in which the parabolas are going to lie on. And the midpoint of the transverse axis is called the center of the hyperbola. So we still just have a center there in the middle, okay? The distance from the center to the vertex is the same on both directions. And inside your parabolas is that's your focus. So just like those parabolas have the focus inside the scoops, the hyperbolas do too. So the distance from the center to the vertex is your A. The distance from the center to the focus is your C. And then the B, those co-vertices, just help you figure out what your asymptotes are to figure out how wide or narrow your parabolas are, which we'll get to in a second. The minor axis, this axis now is actually called minor, is now called a conjugate axis. You won't see that a ton, but just know that that's what that means. So transverse is like your major, conjugate is like your minor. All right, so here's got all the things on your on your hyperbolas. Here's my horizontal hyperbola. In the dead center is your center. This one has a center at 0, 0. Obviously, these are going to move, but this one has a center at 0, 0. From the center to the vertices is that A distance. From the center to the focus is the C distance. And then the co-vertex this time is still B distance away, and it goes in the opposite direction of your A. Except we don't then close this in, we point outward, okay? So you make these a little box. There's two ways to do the asymptotes, but I would recommend the box connecting the coordinate points that are your A distance away and your B distance away, or your vertices and your co-vertices. And then you draw the asymptotes to the corners of your boxes. That tells you how wide your branch is going to be. And then you actually just draw your branch right off the vertex as close to without touching those asymptotes.
So are we going to have to have actual points for the asymptotes?
No, as long as you go through the box.
Okay.
Yeah, you'll have an equation though. I'm going to teach you how to get the equation, okay? All right, so vertical just turns it, right? So this one has a center at 0, 0. The vertices are A distance away, but up and down this time. The co-vertices are B distance away, but right and left this time. The focus is C distance away, up and down, just like your vertices. You would draw the box connecting the points B and A distance away. You then draw your asymptotes through the corners of that box. And then you draw your branches off the vertices as wide as those asymptotes allow you. If we shift the center, because they're obviously not all going to be at 0, 0. If I'm given the equation, I know it's shifted because it's not just going to be an x squared and a y squared. It's going to be an x plus or minus a number and a y plus or minus a number. That's how I know the center is shifted. Then everything still applies. It's just obviously not going to be necessarily symmetric. This is still a distance away from your center. This is still C distance away from your center. And then there are asymptotes here, and they were found from a box you don't even see anymore. But that would be B distance away from your center. So if you were to graph this, it's a pain in the butt to graph these on a graphing utility because you have to solve for y. So you got to get everything to one side. You have to square root both sides. These are a pain to graph on a graphing utility like your handheld. But if you were to just if you were to get it to that point and graph it, you would actually not see the asymptotes at all. You would just see those curves. So the second one is the same, like what happens if I shift it off of center. So you would get a change in your x and your change in your y like we did for the first one. And then everything else is still the same. This is A distance away, this is C distance away, and then the box that was made would have been B distance away. Just goes in the opposite direction. All right, equations of the hyperbola. These are the ones, the ones on the bottom are just simplified. That's if you have a center at 0, 0. I would say just learn the top ones, and then if you make the K and the H 0, 0, you know it. Notice the difference between this and ellipses. What's something you notice is the difference?
When it's A squared, it has to go in front.
The A has to be the front. So A is first this time. Order matters. A is not necessarily larger. A is first.
If you put A first on the other one,
It doesn't matter. What else is different? It's a minus. Other than that, it looks the same. So the minus in between is why the order is important. It's still X minus H. H always goes with X. It's still Y minus K. K always goes with Y. And then A squared, B squared are on the bottom. A is first. So if X is first, this is a horizontal hyperbola. And if Y is first, it is a vertical hyperbola. The other major difference is C squared equals A squared plus B squared. So those equations are the opposites of your standard form. If you think about ellipse, my standard form of ellipse is a plus, but then it's C squared equals A squared minus B squared. If we get to hyperbolas, my standard equation is a minus, but it's C squared equals A squared plus B squared. So they are the opposites of your standard equations. And this is still the same. Transverse axis, which is the same as our major axis, is 2A. Conjugate axis, which is the same as our minor axis, is 2B. All right, so this one says, find the standard form of the equation of the hyperbola with foci negative 1, 2, and 5, 2, and vertices 0, 2, and 4, 2. Actually, hang on a second. Yeah, we'll do this first. Okay. So I'm going to pull in a graph. Again, I will give you scrap paper that is a graph paper this time. I'm going to plot those coordinate points, negative 1, 2, and 5, 2. And those are foci. So just that piece of information alone tells you what? It's horizontal, which means what comes first? X. So it's X minus Y. I just give myself that little, they're going to be squares. They're going to be over A and B. But for me, I just do it immediately. If it's X, if it's horizontal, I do X minus H. X minus Y. Then what else does it tell you? Before you get there. Just off the foci alone, what else can you figure out? The center is halfway between them, or the midpoint between them, right? So I can add the 2x's divided by 2, add the 2y's divided by 2, or count the distance between. And this is why it would be important to have an actual graph so it's accurate. So the center there is 0, 2. So now I have x minus 0 squared minus y minus 2 squared.
Wait, 0, 0, 2.
Ah, 2, 2. Wow. I was just making sure you're paying attention. Good job. 2, 2. I was looking at the vertices, I think. I don't even know how that happened. All right, 2, 2. So x minus 2 squared minus y minus 2 squared equals 1. I already have all of that. What else does the foci give you?
The bigger number is obviously going to be under the x.
That doesn't matter. Remember, bigger number doesn't matter.
Oh,
Yep. A has to come first, but the bigger number doesn't matter. What letter is the distance to the foci? The C, right? So C is what? 3. In either direction you want to count. So C is 3. All that information comes from one set of coordinate points. C is the distance from the center to the focus.
Oh, okay.
So you could count either way, but it's 3. All right, then I have to move on to the second piece of information, which is the vertices. The vertices are 0, 2, and 4, 2. What does that tell you? Good. A is 2 because it's the distance away from the center. So now I know this would be 2 squared, or x minus 2 squared over 4. minus y minus 2 squared. I'm just missing the b. How do I find it?
9 equals 4 plus b squared.
So what is that? What equation did you use?
Oh, c squared equals a squared plus b squared.
Good. Minus. No, plus. You're right. Sorry, plus. B squared. So c squared, which is 9, equals a squared, which is 4, plus b squared. B squared would equal 5. And that's what completes the rest of my equation. You don't need to finish graphing it. If you did, you would square root 5, approximate it to be like a 2.1, which we'll get to in a minute, and then draw the box. Find your asymptotes, find your curves.
You have to put equals 1.
It has to equal 1. Yep. Ellipses and hyperbolas have to equal 1. All right, so the asymptotes. Oh, sorry. All right, so now we get into the asymptotes. Okay, we know the asymptotes is what determines how narrow or wide our branches are. It passes through the center. They intersect at the center, and then they pass through the corners of the boxes. So I think this picture makes it like a little bit more complicated. Here's my center. I'd go right and left the A. This would be for a horizontal one. I'd go up and down the B. And then I make a little box. It can be rectangular in shape or it could be a square. I identify the corners of that box and I draw the asymptotes through the corners, crisscrossing through the center. If it was vertical, I'd have my branches at the top and the bottom. If it's horizontal, I have my branches at the right or the left, and I make them as wide as I can without touching that asymptote. To find the equation of the asymptote, these are lines. So they're going to be y equals mx plus b, but they don't have to be in that format. They give you y equals k plus and minus b over a times x minus h if it is horizontal. And y equals k plus and minus a over b if it times x minus h if it's vertical. So horizontal, the only difference is b over a, vertical, a over b. That's the only difference. You do not need to then distribute that. You can keep it the way that it is. If you wanted to use that to graph your lines instead of the box, then you need to distribute it, which is why I would say just go with the box. The plus or minus means there's two, right? We just drew two lines that crisscross between. That's where the plus and minus comes from. All right, this one says, sketch the hyperbola whose equation is 4x squared minus y squared equals 16. So what's the first thing you notice about this? Doesn't equal 1. So how do I get it to equal 1? Divide everything by 16. So 4 goes into 16 4 times. This is x squared over 4 minus y squared over 16 equals 1. Now it's in standard form. Tell me what you know about this hyperbola. Center's at 0, 0. Horizontal or vertical? Horizontal because the x comes first.
A is 2.
Good. A squared is 4, so A is 2.
And b is 4.
B squared is 4, so B squared is 16, so B is 4.
So c squared is 1.
So C squared would equal 4 plus 16, 20, square root of 20, good. 2 radical 5.
Do you have to simplify it?
It will, if it asks for foci, you're going to have to simplify it to give it to me. If you're just using it, if you're just going to graph it, you're going to approximate. But most likely, I mean, you're going to see a mix of questions, but you're going to get at least one kind of big one where you get the equation and you have to give me all the parts and then graph it. On those, when you give me the foci, you'd want to simplify it. You're welcome, Miranda. Sure. All right, so now I'm going to graph what I've got. So I've got a center at 0, 0. We said it's horizontal, so I'm going right and left with the A. Right 2, left 2, and those are my vertices. Negative 2, 0, and 2, 0. Then I'm going up and down B, which is up 4, down 4, and those are the co-vertices. If it wanted the foci, I'd be going right and left C. So square root 20 is going to be in between like 4 and 5. I would go in between 4 and 5 here, and those would be my foci. If I'm listing them, they're going to be exact. So it's plus and minus 2 root 5, 0. Right and left, 2 root 5. I do not need those to graph it though. So it will probably ask you for them, but you do not need that to graph it. All right, so now I'm going to draw the box.
So the foci shouldn't be in between.
Correct. They're going to be in the scoops.
So outside of the vertex.
Correct. I draw my box, and then I want to draw the asymptotes through the corners of my box. And then we said it's horizontal, so the branches kick right and left.
Are we going to have to find the equation of the asymptote on the test?
Yes, but maybe not all put together, but yes at some point, so we'll do that next. So then this goes this way, and this way, and this way, and this way.
If your box is in vertex.
It's all right. Yeah. If it's, like if it's a question that says to graph it, I'll provide the graph for you right on the test, and that would give you points towards it. Whereas the last one that we just did, I don't need the graph to, like the graph itself helps you with the equation, but it wouldn't be worth points on that question.
For the test, would it be fine if we just write plus minus with the rest?
I can't remember how it is on WebAssign if it separates it out, but on the short answer, you could definitely put plus or minus. Yeah. Okay, so then let's say it asks for the asymptotes. This is horizontal, so it is y equals k plus and minus b over a x minus h. So horizontal is b over a. So I do y equals my k was 0, plus and minus, the b is 4, the a is 2, x minus h, which is also 0. And I get y equals plus and minus 2x. If you graphed y equals negative 2x, you would have gone to 0, down 2 to the right 1, down 2 to the right 1, drawn your line, and that should be an asymptote. And then y equals positive 2x, you would have gone to 0, up 2 to the right 1, up 2 to the right 1, drawn your line, and that's the other asymptote. So you can graph it from your equation, but I think the box is easier, especially when you have something that has an h and a k there, because then you have to distribute the b over a, combine them to the plus and the minus. Question. All right, this one takes it a step further and says, put it into standard form, find the asymptotes, then sketch the hyperbola given by 4x squared minus 3y squared plus 8x plus 16 equals 0. So we can't just divide by a number this time, we got to do what? You're going to complete the square. For the x, but we don't need to do it for the y, right? There's a y squared, but there's no y. So I only have to complete the square for the x. If there was a y squared and a y and an x squared and an x, I'm going to complete the square for both. So I'm going to group together the 4x and x squared and the 8x minus 3y and bump the 16 to the other side. Take out a 4, and I get x squared plus 2x. Leave the space. Minus 3y squared equals negative 16. Take the 2, divide it by 2, that's 1, square it, it's 1. Add the 1 here. Normally I'd add the 1 here, but I got to multiply by 4. So I'm adding 4. I get 4. Square root the first term, square root the last term, take the sign from the middle, put it in parentheses, and square it. Minus 3y squared equals negative 16 plus 4 is negative 12. Then what?
Divide by 12.
Divide by negative 12. So whatever you start with, like if you looked at the beginning, it's an x squared minus a y squared, you might have thought that that was a horizontal hyperbola, but you have to wait till it's in standard form to make that call, because if you're dividing by negative, these signs are switching. So this would be 3, and this is negative x plus 1 squared over 3. This becomes positive y squared over 4 equals 1. So the negative comes second, so I would now switch this order. Y squared over 4 minus x plus 1 squared over 3 equals 1. Now tell me what you know.
A is 2.
A is 2. A squared is 4, so A is 2. What else? It's vertical because the y comes first. And b squared is 3, so b is the square root of 3. What about your center?
1, 0.
Negative 1, 0. So be careful because if y comes first, like for some reason, a third of the people switch that. Okay, remember that the x always goes with the x. Like, so the coordinate of the x always comes first. All right, so now it says to graph it. Oh, I got to find the asymptote still, but I'll go back to that. Asymptotes are y equals k plus and minus. It's vertical, so a over b x minus h. So sometimes, like as soon as I know it's vertical, I write a over b. Or if it's horizontal, I write b over a to remind myself to do that for the formula. So y equals k is 0, plus and minus, a is 2, b is square root 3, x minus a negative 1 becomes x plus 1. We can lose the 0 and we have to rationalize the 2 over root 3. So this becomes y equals plus and minus 2 root 3 over 3 times x plus 1. So that's when it gets even messier to graph based on the asymptotes, and that's when I would recommend go to the box. Like, stick with the box. The box is easier. So if I'm graphing negative 1, 0, there's my center. It's vertical, so I'm going up and down 2. Up 2, down 2. Those are your vertices. Negative 1, 2, negative 1, negative 2. I'm going right and left square root 3. So approximately, what is square root 3? It's a little bit smaller than 2, right? Because root 4 would be 2. So you could say 1.5, 1.8. I don't care. I'm not going to be able to figure out how close you are between 1.5, 1.8. You just have to be in between 1 and 2. So if I move that distance away, it's like here and here. But when I list it, it's going to be exact. So now I'm going left and right. So it is my x, which is negative 1, plus and minus the square root of 3, 0. From there, I make the box. I draw the asymptotes through the corners. And it's vertical, so the branches go up and down. It didn't ask for foci. If you wanted to find it, you'd find c. C squared would be a squared plus b squared. And then you'd go up and down, so you'd change the y coordinate of your center. All right, now we're reversing it again. Find the standard form of the equation of the hyperbola having vertices 3, negative 5, 3, 1, and asymptotes y equals 2x minus 8 and negative 2x plus 4. So I'm going to pull in my graph. I'm going to graph 3, negative 5. And 3, 1. Those are your vertices. So what does that tell you already? It's vertical, which means what comes first? Y. Y squared minus x squared. What else? Center, halfway between these. So my center is 3, negative 2. So now I got y plus 2 squared minus x minus 3 squared equals 1. I already have all of that. A is 3. So a squared would be 9. And then it gives me these equations. My asymptotes are y equals 2x minus 8 and y equals negative 2x plus 4. Now, oh, sorry, go ahead.
How did you know that it was 3?
Because the distance from the center to the vertex.
Thank you.
You're welcome. So they will sometimes give you the asymptotes in terms of like a point slope where your k plus or minus your a over b and x minus h. And then sometimes they're going to give it to you like this where it's already distributed and the terms are combined. Don't allow it to confuse you. You still only need the slope. You still only need what is attached to the x, okay? That is your b over a or a over b in this scenario because it's vertical. This is a over b. So if 2 equals a over b, negative 2 also equals a over b because it's plus and minus. And I know that a is 3. How do I find b?
How'd you get 2?
Because 2 is from here, right? So that's your a over b or b over a. Because it's vertical, it's b over a this time.
Wouldn't it have to
I mean a over b, sorry.
2/3 for B?
Well, this would be over 1. How do I get there? You can either cross multiply b on both sides, and then divide by the 3. I would say cross multiply is probably the easiest thing to do here. This would be 2b equals 3, and then divide by 2, and b equals 3 halves.
So what's that equation?
This is, so your asymptotes, right? Your asymptotes originally start as y equals k plus and minus. This is vertical, so a over b, x minus h. But when they give it to you in point slope or slope intercept format, they already distributed the b over the a over b, and then combine the like terms of the constants. But instead of going through all that work, instead of taking out the 2 and taking out the negative 2, you just have to grab the slope. The slope is your a over b or your b over a.
You equal it to.
And then you'd set it equal to a over b or b over a. So if it was horizontal, I would have set it equal to b over a. And then you're going to have one of those two numbers. You just got to figure out the other one. So if b is 3 halves, what would b squared be? Good. So this would be over 9/4. Can you leave a fraction within a fraction? No. How do I get rid of that 9/4 in the bottom? Okay. Or shortcut, move the bottom to the top. So this would be the same thing as times 4 over 9, right? And then the numerator would get the 4 and the bottom keeps the 9. So shortcut is just grab the bottom of the denominator and bring it to the top. So this would be y plus 2 squared over 9 minus 4 times x minus 3 squared over 9 equals 1. And that is standard form. So if you end up with a fraction in the bottom of that fraction moves to the top of your fraction. The eccentricity of a hyperbola is similar to the eccentricity of the of the ellipse. Okay, it is still c over a. The difference is that now it would be greater than 1. Because your c is going to be bigger than a, your fraction is going to result in something that's an improper fraction, which is what it should be. Okay, when e is close to 1, the branches are more narrow. So this would be something close to 1. They're skinny. When the eccentricity is really big, they are more wide, okay? So again, it just might ask you for eccentricity. It is c over a. The bigger the number, the wider the branch, the smaller the number, the narrower the branch. So you don't have to use it to graph anything, but it kind of justifies your graph. All right, and then the last thing is, I think, the easiest thing in this section is determining what kind of conic it is from your original equation that is not in standard form, it is in general form. So if I have an equation that has one variable squared at least, it could have one variable squared, it could have two variable squareds, right? It actually will not have an xy term. So you won't see an xy term when it's in general form. That's actually when we're starting to rotate. That will come back tomorrow. That is the fun of the rotation of the conic. If your equation says something with an x squared, something with a y squared, something with an x, something with a y, and then a constant equals 0, then you're going to grab the a, which is what is in front of the x, coefficient on the x squared. You're going to grab the c, which is the coefficient on the y squared. And then you're going to have one of these 4 scenarios. If those two numbers are equal, it is a circle. If you don't have one of those two numbers, which means one would be 0, the product is 0, then it's a parabola. If their product is greater than 0 or positive, it is an ellipse. Think about it. An ellipse has a positive sign in between. Okay. And if their product is negative, then it's a hyperbola. Think about it. It has a minus in between. So this is how you can classify your conic from the general form before it's even in standard form. So they would look like this. It says classify the graph of each equation. So look at A, example A. What is A? 4. What is C?
1.
0. There is no y squared, right? So it'd be 0. The product of those two is, which makes this a parabola. If there's only one squared, it's a parabola. It's usually pretty easy to find that one. Go to B.
If you know that it's a parabola,
You don't need to. I think that's one you can find just from looking at it. I mean, you all can, but. B, what would be A? 4. What is C? -1. They are not equal. That's the first thing you want to check. They are not equal. So then their product is positive or negative? Negative, which means hyperbola. Go to C. What is your A? 2. Your C? 4. They are not the same. Again, that's what you want to check first. Their product is positive, which means ellipse. And the last one, your A is 2, your C is, which means this is a circle. So notice in none of them they have an xy term. You're going to see the xy term come into play tomorrow with the rotation. If it is written in standard form like that, then you can determine the conic from the beginning. So before you start to complete your square, you can determine what kind of conic it is. So there will be like one big question that's like complete the square, determine what kind of conic it is. And then if it is a circle, do these things. If it is a parabola, do these things. If it is an ellipse, do these things. If it is a hyperbola, do these things. Questions? Okay, so we're going to stop there today. We pick up with rotations tomorrow. You do have a homework that is just today's lesson. So it is the 9.3 part 1 on WebAssign. You must show work. I'm going to get you if you don't, okay? I graded that 9-1 homework and some people skip some stuff. You have to show work, and you have to, if it says to graph, you have to hand draw it and then select it from your multiple choice. So I should see these graphs, okay? Your test is not going to be multiple choice. You need to know how to graph these. So I would say maybe even pull in either like the sticky notes and make them graphs so that it's accurate, or make your homework background the graph paper, something so that you know you're drawing them accurately. Questions? Okay.